Welcome everybody to Lab 9. Today we are going to be working on independent samples t-tests as well as generating confidence intervals around those means. And finally we're going to be talking about the assumption of variability. Today you're going to need to download Lab 9 Data 1 as well as the lab9.docx handout. So before we begin, we're going to be talking about the same example we use in class. So as a reminder, that is this independent samples t-test of understanding whether or not Sesame Street watching as a child actually influences high schooler grades. So 15 or so years later, does what we watch as a student, as a child, influence our abilities as a student? So in this example, we have 20 participants. We have 10 who watched Sesame Street and 10 who did not watch Sesame Street. And we know that this is a independent samples t-test because we don't have any within subjects process here. In fact, the researchers couldn't. You can't assign some people to watch it and then not watch it, or not watch it and then watch it. They either did or they didn't at this point. We can't change what they did as a child, so we need to just create these two groups, these two different populations of people who watched or who did not watch. And we know that they're independent because the skills and abilities of those who watch Sesame Street should not theoretically affect the skills and abilities of the second population of those who did not. Certainly they're interacting in some way, but these are not associated directly with each other. So we're going to be doing this in PSPP, figuring out how to figure out if the means of one group are different from the means of the second group. But before we get there, we're going to have to organize our data in a specific way for this process. You'll recognize this in-class format of having the watch Sesame Street and did not watch Sesame Street columns with each of the grades associated down the middle. But something you should be noting is that this watch Sesame Street and did not watch Sesame Street, if they were put in SPSS or PSPP as is, they aren't actually variables. They are levels of the variable. We also know that we have subject numbers, and so we might want to include those subject numbers here, but we now see that there would be two subject number variables. Those are the first 10 who are in the Sesame Street watching condition, and those next 10 who were in the did not watch. And it's important to note here that the subject number doesn't have to be the first 10 in one condition and the second 10 in another condition. It could be random all over the place. You could have subject 1 in the first condition and subject 2 in the second and 3 in the first and 4 and 5 in the second. But for the purposes of our example, we're just going to have the first 10 are in the watch Sesame Street and the other 10 are in the did not watch Sesame Street. But again, what we're seeing here is that if we put this in PSPP, we get 4 variables. 2 subject number variables and 2 variables that are actually just levels of the variables. Because what we really care about are the dependent variable of grades. And we see that the watch Sesame Street has that dependent variable in it, and the did not watch Sesame Street has that dependent variable in it. We also care about our independent variable. This is the history of watching Sesame Street. So this has 2 levels, those who watched and those who didn't. So what we want to do here is set up those variables in PSPP, not just have the data all over the place. So we're going to have to reorganize. What we're going to do is actually take the first 10 participants, those subjects who are in the watch Sesame Street condition, and we're going to put them into a new organization that has subject number as a variable and grades as a variable. This is our subject number variable and our dependent variable. So those first 10 are going to go in here, and the other 10 are going to go right after them, keeping consistent that all of these numbers are part of that dependent variable, and all of these numbers are part of that subject number variable. Of course, we're not done just yet because we need a way of telling PSPP that these first 10 were from the watch Sesame Street condition, and these other 10 were from the did not watch Sesame Street condition. So we're going to create a variable that represents our independent variable. In this case, we're just going to call it condition. So this is the either watched or did not watch Sesame Street. And we're going to apply the label of watched or did not watch. So now we have three variables with all of the dependent variable scores and then all of the values for the level of the IV listed here. This is why it's been so important throughout this semester to recognize the difference between levels and variables. It's all about how we organize our data in PSPP. So with that said, we can go ahead and open up Lab 9 data. And here we'll see the three variables: the subject number, the grades or our dependent variable, and the condition variable. And here under value labels, we have the two assigned conditions of watch Sesame Street or did not. If we double click on it, we'll have here a 1 is assigned to watch Sesame Street and a 2 is assigned to did not watch Sesame Street. As you recall from value labels, it does not matter what these numbers are. It could be a 7 and a 99, a 0 and a 1, a -5 and a +6. It doesn't matter as long as they are distinct. And when we go to our data view, we will now see all of our 20 subjects, all of the dependent variable scores, and then our conditions of 1 and 2. The first 10 are in condition 1, the other 10 are in condition 2. And if we toggle our variables, our variable labels, value labels I should say, here we will have all of the different conditions listed out in words instead. And if we wanted to go ahead and get our grades, a mean and standard deviation for our grades, we could go to Analyze, Descriptive Statistics, Descriptives, and move over that dependent variable. Let's get rid of minimum and maximum. Click OK. And then we can go to our output and see that we have that mean of 89 across all 20 participants and standard deviation of about a 6. But of course, with our sample, we don't really want to combine them all together. We don't want to have all 20. We want to know the means of the separate groups. So we've seen how to do that before. We want to split our data so that we see the means and standard deviations for the first condition separate from those in the second condition. So we could go to Data, Split File, and we want to organize our output based on our conditions. Click OK. And now when we go to Analyze, Descriptive Statistics, Descriptives, and I ask it again for grades, it's going to give me them separately by the two conditions. Here's our output, and we see we have the split values. Here are the means and standard deviations for those who were in the watch Sesame Street condition, and here are the means and standard deviations and sample size for those who did not watch Sesame Street. We have 10 participants in either group. We have those means of 93 and 85 that we calculated in class. We also have a standard deviation of both of our groups, which we didn't calculate. But if you look at this slide, you will see that with the sum of squares that we calculated, as well as the degrees of freedom of 9, that 10 minus 1, we could follow through and get these standard deviations of 4.71 for our first watch Sesame Street and a 4.22 for those who did not watch Sesame Street. But the real question here is to figure out, is the difference between the grades in one condition from the grades in the other, is that significant? So here we have a mean of 93 and a mean of 85, so that's an 8-point difference. And we want to know, is that difference actually interesting? Are those big enough of a difference to say something interesting about Sesame Street viewership? And to do that, we're going to have to combine these standard deviations together. We're going to have to pool them together so that we can figure out a standard error of the differences between, of the mean differences between these groups. We're going to do that by running an analysis of an independent samples t-test. Because we are trying to understand our data, we're going to use the Analyze tab. Oh, first also you want to go to Data, Split File, and turn that off. If you don't, you will get a major error. It will say it can't calculate anything. So let's analyze all cases. And now we're going to go to Analyze, And we're going to be comparing the means of the two groups and running the independent samples t-test. When this opens up, it's going to ask for two types of variables, the test variable and the grouping variable. The test variable is PSPP's special code for dependent variable, that outcome we care about. In this case, that's going to be grades. It also wants to know your grouping variable. This is a fancy phrase for independent variable, the variable that we are assigning groups to. So in our case, that's going to be the condition. But we've moved over both of these variables, but the OK is still grayed out. We can't click it. That's because we have to do one more thing for PSPP. We have to define our groups. So what this is asking is, an independent samples t-test is comparing two means. And PSPP doesn't know that you only have two groups. You could have had three conditions of those who have never heard of Sesame Street, or those who watched it a little bit but then stopped, or those who are still watching it today, or those who have siblings who watched it but they didn't watch as a kid. There's all other potential conditions, but we only care about two. So we are going to assign the values for these comparison groups. So in our case, that's going to be group 1 and group 2. We're going to give the values for watch Sesame Street and the values for did not watch. The order of these does not really matter for your analysis, but similar to a dependent means t-test, the order you put in is going to change whether or not you get a negative change, a negative comparison, or a positive comparison. So it's just about your interpretation. Here we're going to put the watched first and the did not watched second. PSPP also has a nice little nice little tool where you can just use the drop-down button and it will give you the labels for each of the conditions. So we could select watch Sesame Street compared to did not watch Sesame Street. And then we click continue. And now we see OK is selected. So we'll click it. And we get our outcome down here. The first section is the group statistics. This is going to give you those means and standard deviations that we already generated above, as well as the sample size. It also gives us our standard error of the means within each group, independent of the other groups. But we know that we don't really care about the standard error or even the standard deviation of these individual groups. We want the pooled standard deviation and, moreover, the standard error of the differences. And to find that, we're going to look in this independent samples t-test table. And we'll skim through and see, here's the standard error of the differences that we got in class. So there's that 2.0. We also find the mean difference of 8, that x1 minus x2, or mean of x1, x bar 1 minus x bar 2. And the t-test we calculated of a 4.0 with the degrees freedom of 18. And this is a p-value, a significance of 0.001. So we know this is significant, and we would report that we reject the null hypothesis and find that, in fact, watching Sesame Street does seem to matter, with those who watched Sesame Street as children having higher grades than those who did not. And how do we know which direction this goes in? How do we know which group was better? Well, we just look at the means. We have two means, and if they are different, then we know that the higher mean is higher and the lower mean is lower. We also see that we don't have to do anything fancy for the confidence interval here. It is centered around the mean difference already. So this has a lower bound of that 3.8 that we calculated in class, as well as an upper bound of 12.20. And you'll notice that the null hypothesis of no difference, of a zero mean difference, is outside of these bounds. It's below this lower limit. So this tells us that we are 95% confident that if we compare any sample, we should get a difference that is, between 3.8 and 12.20. Now, some of you through this might be watching and seeing that, oh, Professor Dooley is highlighting all these numbers that we recognize, but there's another line of numbers here. Why are these different? We have a degrees freedom of 17.78 and a confidence of 3.79 and 12.21. They're just slightly off. And what this is doing is it's giving alternative data, assuming that one of the assumptions of the independent samples t-test has not been met. You might recall from class that we have the assumption that the two samples have similar variability. That is, they kind of have the same distributions. There's not some crazy outliers, or everybody in one group is very similar to each other and everybody in the other group are very different from each other. Usually we assume that the variances are equal, and so we would just use this one line here. But if they are not similar, if you cannot assume that the variances are equal, that the variability are equal, you have to use this second line. Well, how do we actually know that the variances are similar or not? Well, that's what this Levene's test for equality of variance is about, the F-score and the sig here. Levene's test is a null hypothesis significance test that is testing the null hypothesis that the variances are equal. So the null hypothesis is that the standard deviation of one sample is equal to the standard deviation of the other. And if they are not, then we have to accept the alternative hypothesis that they are not. So if we reject the null hypothesis, then we have to accept that the equal variances are not assumed. So in our PSPP, we'll see that the Levene's test has a F-score, which you don't need to know about just yet, but it more has a significance. This significance is exactly like the p-values we've done so far. If the p-value is greater than 0.05, so it's just normal, then okay, the null hypothesis is accepted. But if the p-value here is less than 0.05, then you have a significant Levene's test and we reject the null hypothesis. So if this number is less than 0.05, we have to use the equal variances not assumed line. In this example, this p-value is way above 0.05. We're doing fine, so we'll use that first row. This will usually be non-significant. Usually we will have equal variances assumed, but every once in a while you'll get something that is a significant Levene's test and you'll have to use the second line here. So be on the lookout for that. As always, we're not done until we look at our syntax. So here we're going to be using the same t-test function, and our variables this time is only going to be our dependent variables. So this case, the grades, the outcome we care about. But the line that's really important for an independent samples t-test is this groups variable. The independent variable goes here. You will tell it the variable name for your independent variable, in our case condition, and then within the parentheses separated by a comma, you're going to tell it the values associated with the levels. In our case, a 1 is associated with the Watch Sesame Street, and a 2 is associated with Did Not Watch Sesame Street. Again, these values could be anything, but you need to make sure they match with your with what you've told PSPP. So if you assigned a value of 7 and 999, just put 7, 999. You can also change the criteria to be a 0.99 or a 0.90, but just as you see in all of those other t-tests. But the important take-home here is that the IV goes in the groups line with the values defined within the parentheses. Okay, that's it for now. So this week you're going to be running independent samples t-tests. It is also important to note that from this point on, actually starting last week, you won't always be getting practice problems that are associated with what we demonstrated that week. You're going to have to start deciding which tool is appropriate for certain questions. Best of luck, and let me know if you have questions.